NEC Section 210.52. B2 of the 2005 National Electrical Code states that small appliance branch circuit shall not supply any receptacle or outlet that is part of the permanent wiring of the structure. In simpler terms, circuits dedicated to serving countertop receptacles in kitchens, often referred to as small appliance branch circuits, cannot also feed receptacles located within a kitchen island if those receptacles are considered part of the building's permanent wiring. The reasoning behind this code provision is to ensure that small appliance circuits are reserved for the intended purpose of powering portable kitchen appliances. This helps to prevent overloading of the circuit, which could lead to nuisance tripping of the circuit breaker or, in more severe cases, an electrical fire. When a receptacle is installed inside a kitchen island and intended for regular use, it becomes a permanent part of the building's electrical system. Connecting this type of receptacle to a small appliance branch circuit would violate the code and potentially compromise the safety and functionality of the electrical system. There are a few key concepts to unpack to fully understand this code requirement. Firstly, we need to define what constitutes a small appliance branch circuit. The National Electrical Code defines a small appliance branch circuit as a 20-amp circuit that serves receptacles in the kitchen, pantry, dining room, and similar areas. These circuits are specifically designed to handle the load of multiple small appliances that are commonly used in these areas, such as toasters, coffee makers, and blenders. Secondly, we need to understand the concept of permanent wiring. Permanent wiring refers to the electrical wiring that is installed within the walls, floors, or ceilings of a building and is intended to be a permanent part of the building's electrical system. This includes wiring for lighting fixtures, receptacles, and other electrical equipment that is not intended to be moved or relocated. In the context of the code, a receptacle located inside a kitchen island is generally considered to be part of the permanent wiring of the structure because it is intended to be a permanent fixture. Thirdly, it is important to consider the potential implications of violating this code requirement. If a receptacle located inside a kitchen island is connected to a small appliance branch circuit, it could overload the circuit, especially if multiple appliances are plugged into the circuit at the same time. This could lead to nuisance tripping of the circuit breaker, which can be inconvenient and disruptive. In more severe cases, overloading the circuit could cause the wiring to overheat, which could lead to an electrical fire. So, what is the solution? If you need to install a receptacle inside a kitchen island, you should not connect it to a small appliance branch circuit. Instead, you should install a separate general-purpose circuit to serve the receptacle. A general-purpose circuit is a 15-amp or 20-amp circuit that can be used to power a variety of electrical loads, including receptacles, lighting fixtures, and other electrical equipment. By installing a separate general-purpose circuit for the receptacle inside the kitchen island, you can ensure that the small appliance branch circuits are reserved for their intended purpose and that the electrical system is safe and reliable. To further clarify, let's consider some scenarios to solidify the understanding of this code requirement and its application. Scenario 1 involves installing a receptacle on the side of the kitchen island, facing outward and easily accessible. This receptacle is intended for general use, such as charging a phone or plugging in a laptop. In this case, the receptacle would be considered part of the permanent wiring of the structure and could not be supplied by a small appliance branch circuit. A separate general-purpose circuit would be required. Scenario 2 involves installing a receptacle inside a drawer or cabinet within the kitchen island. This receptacle is specifically intended for powering a built-in appliance, such as a microwave or a warming drawer. In this case, the receptacle would also be considered part of the permanent wiring of the structure and could not be supplied by a small appliance branch circuit. A separate general-purpose circuit would be required. Scenario 3 involves installing a temporary power strip on the kitchen island countertop. The power strip is plugged into an existing small appliance receptacle and is used to power multiple small appliances at the same time. In this case, the power strip is not considered part of the permanent wiring of the structure and is permissible to use with a small appliance branch circuit, provided that the total load of the appliances plugged into the power strip does not exceed the capacity of the circuit. Scenario 4 involves installing a receptacle under the kitchen island countertop, specifically for the bread warmer. This receptacle is intended for the bread warmer only and is out of sight unless someone looks under the counter. In this case, the receptacle would still be considered part of the permanent wiring of the structure, even though it's somewhat hidden. It could not be supplied by a small appliance branch circuit. A separate general-purpose circuit would be required. It is important to note that the specific requirements for electrical installations can vary depending on the local electrical code and the specific circumstances of the installation. It is always recommended to consult with a qualified electrician or electrical inspector to ensure that the electrical installation complies with all applicable codes and regulations. To reiterate the key points, small appliance branch circuits are intended for powering portable kitchen appliances and should not be used to supply receptacles that are part of the permanent wiring of the structure. Receptacles located inside kitchen islands are generally considered to be part of the permanent wiring of the structure. A separate general-purpose circuit should be installed to serve receptacles inside kitchen islands. This ensures that the small appliance branch circuits are reserved for their intended purpose and that the electrical system is safe and reliable. Now let's delve into the broader context of kitchen electrical safety and code compliance. The National Electrical Code has specific requirements for kitchen electrical systems to address the unique demands and potential hazards associated with this high usage area of the home. These requirements are designed to protect occupants from electrical shock, fire, and other electrical hazards. One of the key requirements is the provision of ground fault circuit interrupter, or GFCI, protection for all receptacles serving countertop surfaces in kitchens. GFCIs are designed to detect ground faults, which can occur when electricity flows through an unintended path, such as through a person's body. When a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the flow of electricity and preventing electrical shock. Another important requirement is the use of tamper-resistant receptacles in kitchens. Tamper-resistant receptacles have internal shutters that prevent small objects, such as paper clips or keys, from being inserted into the slots. This helps to protect children from electrical shock. In addition to these specific requirements, the National Electrical Code also has general requirements for electrical installations, such as the proper sizing of conductors, the use of approved wiring methods, and the proper grounding of electrical equipment. Adhering to all of these requirements is essential for ensuring the safety and reliability of the electrical system in a kitchen. When planning a kitchen electrical installation, it is important to consider the anticipated electrical loads and to provide an adequate number of circuits to handle those loads. This will help to prevent overloading of the circuits, which can lead to nuisance tripping of the circuit breakers or, in more severe cases, an electrical fire. It is also important to consider the placement of receptacles to ensure that they are readily accessible and conveniently located for the intended use. In the specific case of kitchen islands, it is often necessary to install receptacles to provide power for appliances and other electrical equipment. When installing receptacles in a kitchen island, it is important to comply with all applicable code requirements, including the requirement that the receptacles be supplied by a separate general-purpose circuit and not by a small appliance branch circuit. Furthermore, the location of the receptacle on the island will have implications as well. If the island is within a certain distance of a sink, then GFCI protection may also be needed for the receptacle on the island. The specific distance is outlined in the National Electrical Code. Also, consider the accessibility of the receptacle. Will it be easily accessed and not obstructed by furniture? Will it be prone to physical damage? These factors might lead to additional requirements, such as using a weather-resistant receptacle or installing the receptacle in a protected location. Now let's discuss the concept of circuit capacity and load calculations. Understanding how to calculate the load on a circuit is crucial for ensuring that the circuit is not overloaded and that the electrical system is safe. The National Electrical Code provides detailed guidelines for calculating the load on a circuit. The first step is to determine the wattage of all of the appliances and equipment that will be connected to the circuit. The wattage of an appliance is typically listed on the appliance's nameplate. Once you have determined the wattage of all of the appliances and equipment, you can add them together to determine the total load on the circuit. The total load should not exceed 80% of the circuit's capacity. For example, a 20 amp circuit at 120 volts has a capacity of 2400 watts, 20 amps multiplied by 120 volts. Therefore, the total load on the circuit should not exceed 1920 watts, which is 80% of 2400 watts. If the total load in the circuit exceeds 80% of the circuit's capacity, you will need to install an additional circuit to handle the load. In the case of the bread warmer, you mentioned that it is rated at 450 watts. While this load alone may not seem significant, it is important to consider the other appliances that may be connected to the small appliance branch circuit. If the bread warmer is connected to a small appliance branch circuit that is already serving other appliances, such as a toaster or a coffee maker, the total load on the circuit could easily exceed 80% of the circuit's capacity. This is why it is so important to install a separate general-purpose circuit for the bread warmer receptacle. By installing a separate circuit, you can ensure that the small appliance branch circuits are reserved for their intended purpose and that the electrical system is safe and reliable. Finally, let's touch on the importance of hiring a qualified electrician. Electrical work can be dangerous, and it is important to hire a qualified electrician to perform any electrical work in your home. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and regulations. When hiring an electrician, be sure to check their credentials and references. You should also ask them about their experience with kitchen electrical installations. A qualified electrician will be able to assess your needs, provide you with a detailed estimate, and perform the work safely and efficiently. By hiring a qualified electrician, you can have peace of mind knowing that your electrical system is safe and reliable. In summary, in EC Section 210.52, the 2 prohibits connecting a bread warmer receptacle inside a kitchen island to an existing small appliance circuit. A separate general-purpose circuit must be installed. Understanding this code requirement along with other electrical safety guidelines is crucial for ensuring a safe and compliant kitchen electrical system. Always consult with a qualified electrician to ensure that all electrical work is performed correctly and safely.